So this was one of the most popular homeworks and recitations in at least my history here at UNC. So let's go ahead and see if we can work through some of these limits together. And we'll start with this one. Remember the main two limits that we're going to remember for these are the limit as x approaches 0 of sine of x over x is equal to 1, and that the limit as x approaches 0 of cosine of x minus 1 over x is equal to 0. So these are the main things that are used in the proof of the derivative of sine of x, and so I guess they're important for us to know. Anyway, getting back to this, we're going to start with this one, and since there is no x, like sine of x over x, I'd like to see sine of x over x, but it's sine of x over sine of x. So what I'm going to do is I'm going to use some mathemagic to just manufacture an x in the denominator. But if I do that, I have to keep things balanced. That's the important thing, is I want to make sure everything's balanced, and so I'm going to put a 3x up here and 2 sine of 7x. So it's important to keep things balanced in your expression. That way it's the same expression. Don't break the rules of algebra. Then after that, I'm going to do the same thing with this sine of 7x. So this looks good to me. And then this 2 times sine of 7x all over 7x. But once again, I've got to make sure I keep things balanced, so I'll multiply this by 7x here. Now let's clean things up, but I'm going to retain these two fractions, this one and this one. And so this will be the limit as x approaches 0 of sine of 3x over 3x times, notice that the x's will cancel there, so you have 3 over 14 times the sine of 7x over 7x. Now, without getting into the gory details of this, just remember that when x approaches 0, also 3x approaches 0, and that this limit will be true no matter what you have in here for the argument. You could have x, you could have a smiley face, as long as that smiley face is going to 0. And so I could rewrite this with with a bunch of 3x's or whatever I need, but let me get rid of my smiley faces for future. There we go. But let's just all agree that since x goes to 0, we'll make 3x go to 0, that you can rewrite this like this, that this will be 1, and this here will also be 1. And so the final answer here is just 3/14. Okay, with this next problem, we're going to want to rewrite this where tangent is equal to sine over cosine. Hopefully that's something you remember from your days in pre-calculus, but if not, I'm reminding of it you now. So tangent is sine over cosine. And so now I'm just going to rewrite this. This will be the limit as x approaches 0 of 4 sine of 2x over x times 1 over cosine of 2x. And one more rewrite, similar to the above problem. Let's see, I'll make this sine of 2x over 2x, and then there'll need to be an extra 2. I think everything is going to balance now. So you can double check, but I believe the 2's balance and everything And so the final step is to recognize that that sine of 2x over 2x ends up, the limit is 1. I've got my 2 times 4 over here, and the limit as x approaches 0 of cosine of 2x. That's there's no problem with that function. It just goes to 1. So this is just going to be 8. This looks exciting. So when x approaches 1, x minus 1 will approach 0. So that's the principle that we're going to use with this one. By the way, with each of these, you should always double check that you end up with 0 over 0 when you plug in the limit. And that will trigger needing to do some algebra or some other things. At any rate, let's go ahead and rewrite this. This is going to be a little dizzying, but bear with me. So there's the first rewrite. Of course, this stuff is just the original denominator. And then I've written tangent is sine over cosine. Then we have the limit as x approaches 1 of the sine of x minus 1 over x minus 1. And then the rest of the stuff is going to go over here. Okay, so we could do this one of two ways. Either we could recognize that when x approaches 1, x minus 1 will approach 0, or I could just rewrite this like this. Just to remind me that that's the case. Either way, this first fraction is going to have a limit of 1. The second fraction, there's no problem plugging in x equals 1 into that fraction, and so we'll have the cosine of 0, which is 1, and x plus 1, which is 2. So the final answer there, 1/2. All right, let's go ahead and try some of these other ones. These I'll try to do a little bit quicker. So this is going to be the limit as x approaches 0 of sine of 3x over 3x. Let's put a 3x over here. And then this is going to be sine of 2x over 2x. And then I'll have to balance that. And I didn't leave myself enough room. Give me a sec. There we go. And I need to have, I guess I need to have a cosine somewhere. So 2x over cosine. So just to explain briefly, I have introduced the 3x, but those cancel each other out, so it's balanced. So these 3x's balance each other out. The 2x's also similarly balance each other out. And then finally, this sine of 2x over the cosine of 2x is the same as tangent of 2x. So everything is balanced here. And so all that's left is to do a little bit more algebra. Limit as x approaches 0. We have this sine of 3x over 3x. And then one of these x's is going to cancel, and you're left with this sine of 2x over 2x times 2 over cosine of x. So hopefully you can see what happened there algebraically. Finally, let's do our limits, and of course, this limit will be 1, and this limit will be 1. So this will be, whoops, I don't need to write limit anymore. 1 times 3 over 1 times 2 over 1. Limit as x approaches 0 of cosine of 2x. Sorry, I just noticed I messed up there. It's not going to make any difference with the answer, but it is the cosine of 2x. But that limit is also, it's 1. Couple more. Wow, that looks like a nightmare. Well, let's do it. So we've got, let's see, let's just proceed as we did before. Limit as x approaches 0 of, we've got the sine of 5x over 5x. I'm going to need more room than this. Hold on a sec. And then multiply this times the cosine of 4x minus 1 over 4x. And then we're going to have to multiply by one more fraction to keep things balanced. But let me just explain where I got what I got. I know that I'm going to want to have sine of 5x over 5x. That's this familiar thing that we've been using all along. And then the cosine of 4x minus 1 should be over 4x. And it's because of this bottom in this glowing pink, purple, fuchsia bubble up there. So that's where that came from. Now, to keep things balanced, notice that I've got x squared already on the denominator. So that's not a problem. What we need to have, though, is we need to have 5 times 4, 20 up here to balance the 5 times 4 that I've introduced on the bottom there, and then the 7 needs to stick around somewhere. So now this is the same. I haven't made any algebra mistakes. I've got everything good, and so now all I have to do is finish this one up. This is going to be 1, this is going to be 0, and then we don't care because we're multiplying by 0, but this will be 20/7. But the final answer here is 0. One more. Wow, we can do this. So next, for this one, I would like to have, in each of these cases, we should mentally check that you have a 0 over 0 situation. And so I've done that. Pretend that I do that with each one of these. So I'd like to have the same argument. On the bottom, I should have the same thing that I have as the argument of the sine on top. And let's see what's going to happen here. I have 2x minus 4 over x squared minus 4. Okay, so that's balanced. So this is going to be fine. I can deal with the sine of 2x minus 4 over 2x minus 4. Since 2x minus 4, as x goes to 2, that expression will, the limit is 0. So we'll formalize that in a minute, but I'm worried about this thing on the right because if I plug 2 into that, I get 0 over 0, so we need to do a little bit more algebra over there. And you know the drill is we're going to do some factoring. So let's go ahead and do that. Whoops. So 2 times x minus 2, and this will be x minus 2 times x plus 2, and then of course you know what's going to happen next is we're going to cancel that stuff. So here we are. So I'll just erase. So that gets canceled with this, whoops. And let's make it look a little prettier. Okay, now I can actually do my limit. If you're worried, you could always rewrite this like this, the limit as 2x minus 4 approaches 0. It's the same thing because as x approaches 2, 2x minus 4 is approaching 0, but that might help some of you sort these things out. So let's see, let's just copy that down here. And then I suppose that that's kind of silly to do this here. We can multiply this by the limit. There we go. Limit as x approaches 2. How's that? Here, put parentheses around this. Okay, so this goes to 1, and this is easy to compute. So my final answer there, 1/2. Hopefully this is helpful. I think that if it is, you should smash that like button and